Good evening, everyone. You are all welcome to Chemistry 416 class for today. My name is Professor Olayinka Ajani. I am your facilitator for this class. Today, between 6 and 7, we are going to be having the topic 2 for week 2 in our facilitation. And as we stay tuned, I want it to be interactive. If you have any questions, you will be given opportunity to answer. But before now, it is expected that the instructional video and instructional material sent to you, you should read and watch them before today's class so that you can bring in to this class any challenges that you have faced in such. So if there's anyone like that, that have one thing or the other that is not very clear, you can let us know so that we can look at it in the topic 2. But if there is no questions or any challenge, then we will need to go through the material briefly. So thank you very much. Please let others be aware of this, that every Tuesday from 6 to 7 is our CHM416 class, Organic Synthesis. Let's always come on time. 7 persons came on board. 5 has run away again. So it's not very encouraging not to be consistent and not to be in the class, because this class we are doing is essentially for your optimum performance and to understand the content of the work, because every of your course material as far as 416 is concerned has been extracted and broken down into 8 PowerPoints each week for each PowerPoint. So if you can follow this teaching judiciously and you watch the video where all those things are fully explained, then at the end of it, you don't need to cram anything. You go to the exam and then you shine. And that's the essence of now investing so much, National Open University investing so much on the e-learning and what it takes for the student to have the best performance. So please, let's encourage others to join as we go along. So last week, we've done the week 1. Today is the week 2. So I'm welcoming you again. Thank you, and stay blessed. So is there any question in the course material for the topic 2? I'm sharing my slide. I want a feedback. Can you see the slide that I just shared?
No, sir, I'm not seeing it.
You're not seeing the slide?
It's still booting, sir.
It's still booting there. Let's wait a little.
Okay, I've seen it.
No, you can now see. Yes, you said you can now see it. You can
Yes,
see it's moving?
I can see it.
Good.
Yes,
So
sir.
do you have any question?
I missed your.
You missed the first one.
I missed the first lectures.
Okay.
This is my
So
first time of joining you.
okay. So let me just briefly explain that. The norms is that we want every student to have full understanding of this and be able to perform well. So what we did is that the thing you need to learn per week, I have already done a video to explain it in detail, and I've already done a PowerPoint to explain in the detail. Before every Tuesday, I will have sent the link of the YouTube video to you. You watch it. It's still 1 hour video. You watch it. Is what we want to cover for the next Tuesday. So when you watch it and you see area where you are not very clear, then you note it down. So when we come to the Zoom live class, you can bring that up as a question so we can use it to go through and explain it. Because the teaching you all over again on the live class today is not, it's like a counterproductive thing, since that video has already taught you. So, but if you have watched that video, so what you will need to do is that before every Tuesday, I'm telling others that are just joining for the first time, before every Tuesday, I will have sent the YouTube link of the video for you to watch on your course page. And I will also upload the course material and PowerPoint there. So once you watch it, whatever it is, what is to be taught are already been taught. So you can now pinpoint whatever is not clear to you. So when we are coming to the Zoom live class, then we can now solve those things and any other question you may have. So that will make it easier that way. But today, because of people are joining us for the first time, if there is no questions on the slide, then let's look at it together. Or if you have not been able to watch the video for today, let's just look at it together. So this is CHM416 Organic Synthesis. It's a 2-unit course. As I've earlier said, my name is Professor Ajani, your facilitator. If you go to the course page of CHM416, you'll see the detail of myself and how you can contact me through my email. If you need anything, I will be there to attend to the need. But the live class will always be 1 hour, which is 6 to 7 p.m. every Tuesday. This facilitation is expected to run for 8 weeks to cover everything that has to do with 416. 1 week was gone last week. Today, there's one that we are going to be doing. So after that, there will be remaining 6 more for us to cover. So I will try and share my thought with you in a minute. So let me just have 2 minutes of your time. Then after that, we'll continue because the people that have joined are not much. So as I was saying, the module 1 is made up of 4 units, unit 1, unit 2, 3, and 4. So the whole of the course material for 416 has been extracted into 8 PowerPoints. Each week, we will deal with each of the PowerPoints. So if we are able to go through the 8 weeks of facilitation judiciously and faithfully, you will not need to have any challenge for you to go for the exam because it's your course material we are going to use to set all the questions that I've taught from page 1 to the last to pull out these 8 weeks of facilitation. So I will advise you not to miss any of these classes. And I will also, after the normal live class, I will do the recording and post it on the course page so that you can watch it over and over again until you grasp what we are trying to explain there. So you have a better chances to do better now with this Zoom joining together with the online facilitation. It makes it better. So last week we looked at the first one, but this week we are going to be looking at the detailed content of this unit. So at the end of this unit, learners should be able to, number 1, define reduction reaction. Number 2, recognize reduction in organic reaction. Then you should be able to explain the type of reduction reaction. The type of reduction reaction. The last week, people didn't come at all on board. I was here waiting for 1 hour. So based on that, as we go along, we'll look for another time to do the topic 1 together so that nobody miss anything. So I will create ancestral sacrifice for my home parts. But here now, we don't have much participants, so we cannot make decision on the time we want to fix for the last week one that we miss. That's why I'm just starting the second week, which is topic 2 today. So topic 1 last week was talking about the oxidation. So today we are looking at reduction. So the reduction reaction, the characteristics of reduction reaction are the opposite of those that we have in oxidation reaction. As a result, organic molecule loses oxygen or gain hydrogen in reduction reaction. So when we are adding more hydrogen, that process in organic chemistry is called reduction. Or when we are losing oxygen, that process is called reduction. And we say it's the opposite of oxidation because oxidation means the addition of oxygen or removal of hydrogen. So reduction is the addition of hydrogen or removal of oxygen in terms of organic chemistry definition. In inorganic, we are talking about the loss and gain of electron. So they are talking about the same thing with different perspectives. So reduction is any chemical reactions involving the gain of electron. Any chemical reaction that involve the gain of electron. Like for example, if you have ion 3 is an ion that has lost 3 electrons. Ion 3 has lost 3 electrons. That's why we call it ion 3 plus. If you had an electron to it, it means that it has gained 1 electron back out of the 3 it lost, so it will be losing only 2 now. So when you have ion 3 going to ion 2, you can see that its addition of 1 electron to ion 3 will help you to get ion 2. So any process of this nature is called a reduction. Or for example, when we are talking about alkene, when we are talking about alkene, which is C2H4, 2 carbon with double bond and 4 hydrogen. Now, if you had a molecule of hydrogen gas to this, it will turn from C2H4 and become C2H6. What has happened there is that double bond has been broken to single bond because 2 other atoms of hydrogen has been added in conjunction to 4 hydrogen atom that you have before. So in this case now, you can see that there's addition of hydrogen to a double bond ethane to become a single bond ethane. This is also a reduction. That's why we say reduction simply means addition of hydrogen to something, or it could mean removal of oxygen from something. So reduction is any chemical reaction involving the gaining of electron, which also means the addition of hydrogen, which also means removal of oxygen. So both catalytic and chemical methods of reduction offer considerable scope in reduction process. Now, the type of reduction. We have catalytic and chemical method of reduction, and they are noted in various dimensions. Method of choice in a particular case will often depend on the selectivity required and also on the stereochemistry. Reduction can be achieved in 3 different ways. The first one is catalytic hydrogenation. That means you are adding hydrogen. Remember, the definition of reduction can be addition of hydrogen. But hydrogen being gaseous in state, you cannot just add it to a compound. There must be something that can help you to add it and enhance it to bind well with that thing you are adding it to. And that's the use of catalyst. And that's why we are saying the first way to achieve reduction is by catalytic hydrogenation. The word hydrogenation means addition of hydrogen in the presence of catalyst. So we are going to be looking at how we are adding hydrogen to get reduction process done and different kinds of catalysts that could be used in different kinds of hydrogenation reaction. The second method of reduction is reduction by hydride transfer reagents. A hydride simply means hydrogen in the negative form. Example of hydride transfer containing agent is boron. When hydrogen is positively charged, you call it proton. At that time, it's acting as if it's a metal. Hydrogen is unique in periodic table because hydrogen can also gain electron. When it happens, it's nitrogen in negative charge, is called hydride. So hydride means hydrogen in negative form can also be transferred through a reagent. You see, the first thing here is hydrogenation reaction in presence of catalyst, adding hydrogen as like a metal in presence of catalyst. Hydrogen can also be a negatively charged species, which can be transferred through some reagents. When you have negative hydrogen, we call it hydride. So the second method is hydride, reduction by hydride transfer reagents. Example of those reagents is boron, boron. Okay. The third method of achieving reduction that we're going to be looking at is reduction by dissolving metals. Reduction by the process of the dissolving metals. So let's look at some processes that involve reduction. A primary alcohol going to aldehyde, of course, you remember that that is an oxidation reaction. But if you are coming from aldehyde back to alcohol, then that will be the reduction process. They are just like word and opposite. They are just like word and opposite. So the processes involved here, we have the primary alcohol giving room to this, and that's oxidation. But if you want to actually appreciate the reduction, you must first of all understand the oxidation. So I will show the difference. How do you know when you are oxidizing? How do you know when you are reducing? Now, if you look at this, any hydroxy-containing compound is an alcohol. But there are three different kinds of alcohol. We have the primary, we have the secondary, and we have the tertiary alcohol. We have the primary, we have the secondary, and we have the tertiary alcohol. Primary alcohol can be oxidized to aldehyde, and uncontrollably, aldehyde is further oxidized to carboxylic acid. However, if we are dealing with the processes that has to do with that, then it is very important that we remind ourselves that what is a primary alcohol? It's crucial for you to know and be able to distinguish. Let's start by saying carbon in group 4 is a tetravalent metal. Tetravalent means it has 4 bonds entering into him. How that 4 bonds will be arranged is what depends on whether you are having alkane, alkene, or alkyne. But all the time, it must not be more than 4 bonds. It must not be less than 4 bonds. When all these 4 bonds are single bond, then we have the saturated one. It is also possible that you can have a double bond. Since you have double bond, you need 2 more to form 4 and 2 single bond. When that happens is unsaturated one, we can call that alkene. It is also possible that this carbon can have a triple bond, which is made up of 1 sigma and 2 pi bond. And when that happens, it will need just only 1 more to make 4 bonds around the carbon center. That's when we have alkyne that end with I. So if it is purely hydrocarbon, that's why you have it. If it's purely hydrocarbon, the double bonded one is alkene, and the sub bond one is alkane. So if we are looking at every of these, there are 4 bonds that come to that carbon center. So when you look at the OH is on a carbon, that carbon is called carbonyl because it's the one that carries the oil. This carbon is carbonyl. Any other carbon attached to it is not directly linked to OH. So now when you look at this carbon that directly bound to the OH is what will determine the fate of whether an alcohol is primary or secondary or tertiary. Let's look, for example, methanol. Methanol is CH3. It has 1 carbon, 4 hydrogen, and 1 oxygen. This is methanol. Any 1 carbon system is met. 2 is et, 3 is prop. I hope we know all those ones. Now, when we look at this, it means that this carbon is bonded to 4 single things. 3 of them are hydrogen. You remember carbon must always be tetravalent. 3 of them are hydrogen. And the last one of them is OH. When you look at this compound called methanol, you discover that the carbon that is linked to the OH, which is this carbon, anytime that carbon linked to OH is not linked to more than one other carbon, then it's a primary alcohol. It can link all to the hydrogen as you have in methanol, 1 hydrogen, 2 hydrogen, 3 hydrogen. This is a primary alcohol. If it's also having 1 carbon linked directly to him and is having 2 hydrogen, then this is also primary alcohol. But immediately this carbon of carbonyl is linked to 2 other carbon directly. Like when you have something like this, let's say this is your carbonyl. The carbonyl is the C that linked to OH. Let's say it's now linked to a carbon here, it linked to a carbon here, and it links to an hydrogen here. If you look at this, the carbonyl carbon, which is the one circled with the OH, is linked to hydrogen here, to carbon here, to carbon here. So a direct link of this carbonyl is to 2 other carbon, 1 and 2. In that perspective, you have a secondary alcohol. However, if your carbon that is carrying the OH, which is called the carbonyl, you know it already had 1 bond, it remains 3 for tetravalent to be fulfilled. If that carbon is linked directly to 1 carbon, 2 carbon, 3 carbon. In this situation, the carbonyl carbon is linked to 3 other carbon directly, 1, 2, and 3. So this is a tertiary alcohol. This is a tertiary alcohol. And that's why I'm saying that to appreciate the reduction we have to look at, let's have a briefing on the oxidation. So when you look at this alcohol, what class of alcohol do we expect this one to be? You can see this carbon, which is a carbonyl carbon. You can see here that is linked to that carbonyl carbon. Let's space out the bond on this carbonyl carbon. Then we can appreciate whether it's primary or secondary or tertiary. Let's say that carbon is this. He has used 1 to link with the carbon down. Now it's using 2 to link with 2 hydrogen. And it's using the last to link to OH. This is this. Condensed form of this CH2OH is like this. It's linked to a C here. This C is this C. It's linked to 2 hydrogen, which is first one here, second one here, and it's linked to the OH that makes it an alcohol. That is this one. So when we look at this carbon, it's a carbon of a carbonyl. Out of his other 3 bonds, is only 1 he has used to link. It's immediately this. I used the wrong Zoom link. The Zoom account. It's 40 minutes. One. He said in the next 10 minutes, once you finish in the next 10 minutes, just go and use that link to join back. Just use that same link you join by. But next week, I'll use the one that have 1 hour for the class. Okay. So this is a primary alcohol. When it's increasing, when it's oxidized, it oxidizes to an aldehyde. An aldehyde is CHO. If you look at the difference between here and here, how do we know whether it's oxidation and reduction? Because in this case now, we said a reduction can be removal of oxygen. If you look here, it's only 1 oxygen you have. If you look here, it's only 1 oxygen you have. So in the case where the oxygen are the same, you may not be able to use oxygen to justify whether it's a reduction that has happened or whether it's oxidation that has happened. But apart from reduction or oxidation using oxygen to define, you can also use hydrogen. So in this case now, If you look at the first one, you have that it is having 1, 2, 3. There are 3 hydrogen linked to that carbon. This one, there's only 1 hydrogen linked to that carbon. So it means from this part going to this part, it has experienced removal of some hydrogen, even though the oxygen atom remained the same. Therefore, because it has led to removal of more hydrogen, it means it's an oxidation process. Because oxidation means removal of hydrogen or addition of oxygen. Let's look at this second one and give an example of what has happened there. Now, looking at this second alcohol, what class of alcohol do we think it is? This is the OH, and this is the carbonyl carbon that linked to the OH. I've told you that whatever class of alcohol you have will be depending on this carbonyl carbon. This carbonyl carbon is linked to hydrogen here, and linked to only 1 carbon here. What class of alcohol should that be? Can somebody help us? What class of alcohol should that ethanol be?
Secondary alcohol.
In the secondary alcohol, I say your carbonyl, which is this carbon, must be linked directly to 2 other carbons. But if you look at this carbonyl carbon, out of its 4 bonds, it's using 1 to link with hydrogen up, 1 to link with hydrogen down, 1 to link with OH that make him an alcohol, and 1 to link with only 1 carbon. Therefore,
Primary alcohol.
It's a primary alcohol. But if instead of this hydrogen, I put another carbon here, like this CH3, to make its own 4 carbon. So if you look at this now, the carbonyl carbon here is linked to 2 other carbon. The first one is here, linking to it. The second one is here, CH3 linking to it. In that case, it will be a secondary alcohol. It's very important for us to know the difference so that we can know what products can be formed out of them. So this is primary alcohol. It's still primary alcohol here. It oxidized to ethanol, from ethanol to ethanol. Why is there an oxidation process? And somebody else. Why is there an oxidation process? You can use either oxygen or hydrogen to know. In this case, when there is no valence charge. So, how many oxygen do we have for ethanol? 1. How many oxygen do we have for ethanol? 1. So we cannot use oxygen to know whether it's oxidation or reduction. So the next thing we have to fall back on is the hydrogen. So around this carbon, direct link to him is 1, 2, and 3 hydrogens. But around this carbon is only 1 hydrogen. So we can say going from here to here, there is a removal of hydrogen. So it means that ethanol going to ethanol is an oxidation process. And of course, in the first unit, we talk about various oxidation agents and oxidizing agents and when they can be useful. So in a primary alcohol, it will go to aldehyde, but there will be selective need to do what is right. So oxidation of secondary alcohol, so oxidation of primary alcohol will give aldehyde, and from aldehyde, it will go to carboxylic acid. But if you want it to be selectively stopped at the aldehyde section, then you have to select the right reagents. The reagent to use if you want to selectively stop at aldehyde is pyridinium chlorochromate, which is called PCC. It's part of the first lecture. You understand it better when we go back to the first lecture. So the secondary alcohol here is example of secondary alcohol is what you have in A here. There are some reagents. The sodium dichromate is a good oxidizing agent for secondary alcohol. The oxidation of secondary alcohol will go to ketone and it will stop there. And when you look at it, of course, also here, what makes us to know that it's oxidation is this. If you look at it here, there's only one oxygen. If you look at the product here, there's only one oxygen. But around this carbon center that have that oxygen, this one has two hydrogen directly linked to that carbon. This one has no hydrogen directly linked to that carbon. So this seems to mean removal of hydrogen. So from you to go from here to here is a removal of hydrogen, and that's an oxidation, because oxidation simply means addition of oxygen or removal of hydrogen. If oxygen is not increasing, then if hydrogen is reducing, it is still oxidation.